Engineering at National Institute of Technology, Rourkela. So, today we are going to discuss introduction to neural network and deep learning. So, in this lecture we will start a basic introduction to neural network, then I will go through the mathematical model for the neural network, then we will go through how to train a neural network by using the differentiation and its application to train a neural network. Then we will dive deep into the deep neural network concepts and we will discuss some of the recent advancements on activation function, weight initialization, dropout, regularization, batch normalization and different optimizers. Then finally, we will discuss how to build and train a deep neural network and improve its performance by optimizing its hyperparameters by using different techniques. So, before going through this, let us see what exactly an artificial neural network is. So, an artificial neural network is a mathematical model that loosely simulates means it does not exactly capture the every detail of biological nervous system, rather it loosely simulates the structure and functionality of biological nervous system to map the inputs to the outputs. So, as an artificial neural network is a simulation of biological nervous system, let us first see how a biological nervous system works. So, a biological nervous system has basically three parts, one is receptors, second one is neural network or brain and the third one is effectors. In order to understand these three parts, let us take an example. So, suppose a mosquito is biting on your left hand. So, what happens? Your right hand immediately goes and kills the mosquito, right. But let us see in a step by step way what exactly happens internally. Suppose a mosquito is biting to your left hand. So, a stimuli is generated through the left hand and it is transferred to your brain, right. Then the brain may directly take a decision based on the past experience, or what it can do, it can instruct another receptor organ like your eye, go and see what happens on the left hand, and your eye looks and takes an image, right, and it recognizes that it is a mosquito, then it informs the brain that a mosquito is biting. So, you see the communication between the receptors and the brain is bidirectional. So, it may happen multiple times before the brain takes the final decision. Then once the brain takes the final decision, it produces the output through the effector organs. So, it instructs the right hand, go and kill the mosquito. So, you see receiving the inputs and producing the output is not difficult, but producing the right output from the input, that is making decision, which is a part of the brain or the neural network, that is very crucial. So, let us understand how our brain works. So, our brain consists of millions of neurons with trillions of interconnections among them. So, you see, yes, there are millions of neurons, but the interconnections are trillion. So, one neuron may be associated with multiple other neurons, right. So, the basic building processing unit of the brain is neuron. So, a neuron has basically three parts, one is dendrites which receives the input signals, and the cell body which produces or which computes the weighted summation of net inputs, and it passes through an activation function to produce the output response to the net input what it receives, then it produces the output response through the axon. So, the dendrites which receives the input, it may directly receive the input from the receptive zone, or it may receive the input, that is the output of another neuron. So, if the dendrites receive the input directly from the receptive zone, they are called as basal dendrites, and if the dendrites receive the output of another neuron as input, then those are called as apical dendrites. And you see the output that is produced by the neuron through the axon may be taken by the another neuron as input at a place that is called as synapse. So, let us mathematically look, or let us mathematically model this biological neuron to an artificial neuron, right. So, you see the inputs that is received by the dendrites is same as inputs that we will give to a neuron, right, that is x1, x2, xn, and each input is associated with a weight. So, let me give you one example so that you can easily understand. Suppose we are sitting in the class and listening to my lectures. So, you might give some importance to my lectures, then at the same time suppose a mosquito is biting to you, right. So, that is also another type of input. Suppose you are giving very less weight to the mosquito biting input, then you will say that, sir, I am so much indulged in your class that a mosquito or several mosquito has bitten me, but I could not realize that, because you are giving more in weight to my input rather than you are giving and you are giving less input to weight to the mosquito biting inputs. So, what we are doing, multiple inputs are coming to our brain and we are giving weight to each kind of inputs. Then based on the weighted summation of inputs, we are providing an output response. So, you see, suppose a mosquito is biting to you, you are again not biting the mosquito. So, whatever input you are getting, the same thing you might not produce as the output, but what you are doing? You are instructing your other hand to go and kill the mosquito. Means based on the net input what you receive, you produce an output response. So, similarly, in order to produce the output response to the net input what you are receiving, you are using an activation function that maps the weighted summation of net inputs to an output response. So, in order to understand this, let us go through a kth neuron. So, let me take a neuron which has n number of inputs x1, x2, xn, right, and each input is associated with the weights w1, w2, wn, and we are having an additional weight that is called as bias. I will explain mathematically why we are using this bias. So, the input to this weight bias is always 1, right. So, why that is, that also we will see, right. Then what we will do? We will compute the weighted summation of inputs, that is w1 x1 plus w2 x2 plus wn xn plus bias, and I can denote this by using a summation notation, that is nothing but summation of j equal to 1 to n wkj into xj plus bk. Then we will pass it through an activation function to get the output. So, yk is nothing but f of bk, right, where f is any function. Usually the function should be differentiable if we are going to use gradient descent to train our neural network. We will see more on that in the coming lectures. So, let us see what exactly we are doing in neural network and why we are doing these things. For that, let me take a single neuron model which is again a linear neural network, that is I am using a linear activation function. So, this single neuron has a single input. So, for simplicity I have used a single input x, right, which is associated with a weight w, right. So, then how we are computing the net input? It is nothing but w into x plus bias. Then as here we are using a linear neural network, we are using a linear activation function. So, what will be the input? The same thing will be produced as the output. So, yk is nothing but f of vk, f of vk is nothing but w into x plus bias. So, let us see what we are doing exactly over here. For this, let me go through a data fitting application. Suppose we want to predict the weight of a person based on the height, right. So, there is no mathematical equation which can predict the height, the weight from the height. Although we may use body mass index reference, but we do not follow body mass index. So, what we will do? We will measure the height and weight of a sample of persons, then we will fit a straight line to it. So, then when we want to predict the output or weight of a new person, let us say mine. So, my height is 5 foot 5 inch, that I will give as input and it will produce the corresponding weight, let us say 78 kilo, right. So, here what we have done? We have fitted a straight line to the data. Fitted a straight line to the data means what is the equation of straight line? It is nothing but y equal to mx plus c. So, now we have obtained the value of slope m and the intercept c, so that we can map the input x, that is height, to the output y, that is the weight, right. So, here in order to fit the data we need to compute the, or in order to fit the straight line to the data we need to compute the error. Okay. Thank you.